What's going on, everybody? Welcome to the second lecture video in the AI for Aspiring Researchers lecture series. Today we're going to be going over linear regression with Sklearn. So let's get started. Alright, so the first thing that we're going to do is we're going to title our Google Colab notebook. And for those of you that don't know Google Colab, it's basically just an extension that you can use on your Google Drive that allows you to write these notebooks or write these Python code directly onto your drive rather than having to use Anaconda or Jupyter Notebooks or anything like that. And so we're going to be using Google Colab. Alright, so the first thing that we're going to do is title our notebook, and we're going to just call it Linear Regression with Sklearn. Alright, so in the code, the first things that we're going to do is import all of the necessary libraries. And so the first library that we're going to go ahead and import is import numpy as MP. Now what numpy is it's basically just a library that allows you to do matrix calculations much faster. And it's one of the most fundamental libraries, and that's kind of the basis for why you see a lot of machine learning applications these days written in Python, because it has libraries such as NumPy or some others that you'll see soon, and it allows you to do these high-level machine learning tasks much faster, and the coding is significantly easier. Alright, so that's NumPy. Now the next one that we're going to do or import is import pandas as PD. Now what pandas is it's basically just a data kind of analyzing library that allows you to look at these different sets of data in tables or some sort of things that allow you to kind of visualize it or create data frames from it, and we'll be doing that in this video just in a moment. Awesome, so the next library that we're going to be importing is import matplotlib.pyplot as plt. Now what this is, it's basically just a graphing library, right? So we have our data and we need to be able to visualize it. And so that's what matplotlib does. It allows us to physically visualize that data that we're taking in as an input. Okay, so now these three are our main libraries, but we're also going to be doing or using sklearn, and specifically in there linear regression, because obviously this is a linear regression video. Okay, so we're going to be going ahead and importing from sklearn.linear model import linear regression. Alright, so this is fairly self-explanatory. All this is doing is it allows us to use the linear regression package within sklearn for our datasets. Okay, so the next thing that we're going to do is import datetime as dt. Now, whoops, I cannot spell today. Nice. Okay, datetime as dt. Now, in our video right here, what we're going to be doing is we're going to be using stock data as our kind of just a data to see and run linear regression on, just as an example, right? Because especially in stocks, it's really important to figure out where stock is going to go in the future, and so we can use linear regression to kind of get an idea of it. And date time is important because within stocks, you don't store it as numbers, you store them by the day, right? So you say at the end of this day, this was a stock price, and so we're using date time just for that. Okay, and also another thing, because it is because we're dealing with the stock prices, is we're going to say import pandas underscore data reader dot data as reader. Okay, so what this is basically doing is, rather than having to consistently essentially download all the data required or all the past stock price, we can just pull it directly from the internet, and so you don't have to, you basically cut out that downloading part necessary. And so these last two libraries right here are basically for the stocks, and these are the actual kind of machine learning libraries that we're going to be using and looking at in this video. Alright, so let's go ahead and jump it right into that. So let's just run this, and we'll wait for it to run. Okay, so now that that's done, well, the first thing that we're going to do is put a start time. So we're going to say start is equal to dt dot data, or sorry, date time, and then we're just going to say 2016-11. Now what this is doing is basically when we gather all the stock data, it's going to give us all the stock data from the very beginning of that stock. And so that's not what we want, because that's just a significant amount of data. And so for simplicity, all we're doing is we're saying that the start data is going to start, or the data is going to start from this date, which is essentially 2016, the year 2016, 1, which is the month, so January, and 1, which is the day, so first. So it would be January 1st, 2016. Okay. Now the next thing that we need to do is create our data frame. So before I told you when I was talking about the pandas library that it basically allows you to use data frames. And so that's what this is. Data frame is just basically kind of, you can think of it a tabular format of all the data that you're going to use. And so what we're going to say is df, which is the typical notation for data frame, is equal to reader, which as you can see here is this thing right here. This is the library that we imported, reader dot data reader. And then now we're going to do a couple things. So it's going to need a couple inputs. Alright, so the stock data, or index data I should really say, that we're going to be using is the S&P 500. So if you don't know what that is, it's basically just the index of all the top 500 companies in the stock market at that time. Right, and so the ticker for the S&P 500 is SPY. Alright, now the next thing that we're going to be doing is we're going to say where do we want this data from, right? Because this thing is reading it off the internet. So where in the internet do we want it? Meaning there's different finance kind of websites that pull from it, right? So you have Google Finance, Yahoo Finance. In this one, we're going to be using Yahoo. So we're just going to type Yahoo right there. Right, and now the next thing that we're going to do is start, right? Because that's the date that we want to start. You can also give it an end date. For now, I'm just going to give it as start, because what that's going to allow us to do is it's just going to bring it up all the way up to today, or the last noticed or last seen kind of data point, quote unquote. Alright, so that's that. And now what we're going to say is df.head. Right, so now what df.head is, it's basically going to show us the first few values of that data frame. And so now we'll see what that exactly does. Right, so as you can see here, this is the 2016-14. Okay, so what this is basically, this is a little weird, but the reason it doesn't start exactly on 1/1 is because in the stock market there are different holidays. So obviously January 1st is New Year's, so the market wouldn't be open then. And then second and third were just kind of weekends. And so because of that, the first day of that year that the stock market actually opened on was the first or the 4th of that month, 4th of January 2016. Right. And so now another thing that you can see here is look at how nicely like tabulated all this data is. It's formatted very properly, and that's why the pandas has so much power, because it's very clean. It's very visually appealing to just look, right? So if I asked you what is the volume, say, of this thing that was traded on, say, the 6th of January, it's very easy to see exactly what that was. It's this number right here. Now, for our purposes, what we're going to be doing is we're going to be looking at the adjusted close. Now, if you don't know what this is, the adjusted close basically just means that this is the stock price of that index price at the end of the day. And what the difference is basically adjusted close versus close is it just kind of takes into consideration stock splits. Now, I won't really go into what those are, but all you need to know is that these are, sorry, this last column is what we're going to be dealing with as our numbers. Okay, so now I told you that we would be physically visualizing what exactly we're running linear regression on to see whether or not it actually works, right? And so the thing that we're going to be doing is we're going to be plotting this, right? So we say plt dot plot, and now inside the parentheses, we're going to say df open bracket and then quote adj close. Now what this is going to do is it's going to pull all the data in this adjusted close column right here, all the way until right now, the last data. And also one more thing I want to add is right now over here, you see that this data is only between 2016 uh, January 4th to January 8th. But just to make sure that it actually got all the data until today, what we're going to do is say df.tail, right? So head, basically what that was doing is it gave the first 5 pieces of data. Now what df.tail is going to do is it's going to give us the last 5, right? And so now let's check that. And surely enough, it does, right? It gives us this 2025-22. Awesome. So plt.plot df adjusted close, right? So that's going to gather all the information from this adjusted close column. And we're going to say now plt.show. And that's basically going to draw the plot. And surely enough, it does, right? So this is the plot that you see. This is the plot that you see for this data, right? So this is the adjusted close over time, right? So you start over here, you started small, and then you come around to this 395 number, which seems to be about right. So this, I think, data looks good. This looks good. All right, so now what we need to do is we need to kind of prime this data in order to run it through our linear regression kind of method from that library that we installed initially right here, right? And so what we're going to do is we're first going to make kind of the x values, right? So if you notice here, what we're doing is we're dealing with date as an index, but when we're doing linear regression, we can't input a date. We only have to input numbers, right? And so what we're going to do is we're going to say x is equal to np dot arrange, and I'll talk about each of these things and what they're doing in just a moment. So 0 to df dot shape, and then 0, and then dot reshape, reshape -1, 1. And then what we're going to say after that, that is not right. Hold on 1 second. Awesome. Okay, so now y is equal to df and then adjusted close 2 underscore numpy. Alright, so what this is doing is what we're basically saying is that this x is going to equal np.arrange 0 to df.shape 0. And what that's going to do is it's going to essentially create an np or numpy array of all the numbers between 0 and the df.shape 0. Now, df.shape essentially just means the number of columns in this data frame. That's going to be df.shape, right? So I'll just open a new block of code right here, copy paste that so you can see exactly what this number is. So df.shape 0, right? So in this case, it's 1105, right? So what that means is that there are 1105 data points in this column, which makes sense because remember, we're doing it from 2016, January 1st, all the way up till today. And right, so the number of days excluding holidays in that time period is going to be the 1105, right? So what this is going to do is it's going to create a numpy array of all the numbers between 0 and 1105. Right, so now what y is doing is it's just gathering all these values, the actual values of adjusted close, and just sending it to a numpy array for later so that we can throw it into our linear regression model. Alright, so I'm going to let that run. Okay, now what we're going to do is we're going to say regression, right, regression is equal to linear regression dot fit x, y. Right, so I think this seems pretty fairly self-explanatory as to what this is doing. We essentially create a linear regression model, or we create an empty linear regression model, and what we're doing is we're fitting it on this XY data, right? So this is essentially the XY data that we're using. This is the x-axis, this is the y-axis. So the x-axis is, you can kind of think about it, the number of days since, or the number of trading days since that first 2016 January 1st, or I guess January 4th. And then the y is the actual value of the stock, or the closing value on that day. And so that's exactly what we're trying to fit, right? So what we're going to do is we're just going to run that as well. And now what we want to do is see, well, how well did this regression model actually kind of predict the data, right? And so in order to do that, all we have to do is say regression dot score, dot score x, y, right? And so that gives us this number, this 0.8807. And what that basically is saying is that, well, this regression model, it was pretty accurate. It was pretty good because this typically range is to a max of 1. And then so getting 0.88 means that it's fairly accurate for what it's worth. Okay, but more than the score itself, I want to actually show you guys this line that we're plotting, right? And so what we're going to do is, since this is a linear regression model, we can use the linear equation, y is equal to mx plus b, right? And so using this same exact package, this linear regression package, we can actually immediately get that y is equal to mx plus b, or the m and b values for that equation, right? And so what we're going to do is we're going to say m is equal to regression dot underscore 0, and so that just means of regression dot coefficient underscore 0. So this is going to give us the slope of our linear regression, and then b is equal to regression dot intercept. And so what that's going to do is it's just going to give us, as you might have guessed, the y-intercept, right? And so now let's just make sure that we got good values. And so what we're going to say is m, and we're just going to print m, and we're also going to do print b, and then b, right? And so now we're going to let that run, and these are the values that we get, right? So we get a slope of 0.1149 around, and a b value of 185.257-ish, right? And so that's what we see as our slope and y-intercept. Once again, that's amazing, but we want to actually see the graph. And so now what we're going to do is we're going to kind of create two separate or new arrays, right? So what we're going to do is we're going to say, one second. Okay, so we're going to say the x fin, so I'm just going to shorten that for like x finish kind of, is going to equal to np dot linspace, and in this parameters, the parameters that we're going to give it are 0 df.shape 0. So once again, that's just the number of columns in our data frame, and then df.shape 0. df.shape 0. Right, and so now we're going to do say y underscore func, that's just a y function, is going to be m times x underscore fin plus b. Now, right off the bat, you see that this y function mimics that y is equal to mx plus b really well, or it's exactly that, right? So you have your m times x fin plus b. The only difference is, instead of saying x as just a number, it's an entire array, because that's what this np.linspace is doing. It's giving us an array of all those numbers in between from this 1 to the df.shape 0, right? So that's the 1105. And so this y function is going to also become an array, and for every value in xfin, it's going to multiply that value by m, and then add that value by b, and you're going to get that y func. Okay. Now what we're going to say is, now we're going to actually plot this linear regression model, and we're going to say plt.plot x underscore fin, y underscore fin, and we're going to give it a little tag right here, so -r. That's going to just mean that our thing is going to be a straight line and red in colors. R stands for red, and label is equal to lin reg. Awesome. So label just kind of identifies what exactly the line is called, right? So we have like a legend that's exactly what the label is. So now we're going to say plt.legend, and this is the location of it, loc is equal to lower right. We're just going to put it in the lower right corner for now. And once again, plt.show. And so that's going to show our graph. And so now let's see. Oh, yfin. Oh, whoops. This isn't supposed to be yfin. It's supposed to be yfunc. Alright, so now let's run that again. Awesome. So you see this graph right here, and this is our linear regression model of that graph. Okay, So now let's do this graph, meaning the linear regression. Let's actually put it on top of this graph to make sure that it was actually working properly. And so rather than just coding it again, I kind of just want to just show you it by copy pasting because I am highly lazy. So we're going to do that, and we're just going to say x, and then we're going to put our label equal to SPY. That's cool, ticker name. But S&P 500, right? So this is going to graph our S&P 500 data. Then what we're going to do is we're going to say copy paste this guy right there, and same thing, right? So our legend and plt.show. Alright, nice. And sure enough, we get this really nice looking graph, right? So you see that basically what's happening is we have our linear regression model pointing this way, and all of our stock data on the blue line, which is denoted by the S&P 500 or SPY, and LinReg right there. And you can see that it's a pretty good graph. And so basically, you know that this linear regression was actually a really nice fit for the graph as well. Now, a word of caution that obviously linear regression might not be the best thing for this graph, because you can see that there are several different like peaks and troughs all over the place, right? So you see one right here, here, and then you big one right here, and a big one right here. And so linear regression, though overall it's pretty good, you might want to try using a different model, say if you're looking for the stock price over the next 10 days, right? Because then it might be a little bit more volatile or a little bit more variable, as opposed to this clean nice line on linear regression, right? And I think one good way to see that is over here towards the end. This is kind of when the coronavirus this is kind of when the coronavirus outbreak hit and the economy took a dip. And so kind of predicting that the economy of the S&P 500 would be up here when in reality it's down here isn't probably the best thing to do. You might want to look at just say the past 20 days and then determine basically that this is going to be the newest value, maybe somewhere down here as opposed to all the way up here. But I think linear regression is one of the best ways to get started in machine learning, and it definitely proved to give us relatively good results. And as you can see here, it even gave us a pretty high score. It gave us a relatively high score. And so over between the 2016 January 1st to now, you can fit this linear model really well, right? And so right now I'm actually doing it with stock prices, but you can do it with almost any sort of data. All you'd have to do is essentially create a column of data, right? So you'd have this right here, we have our adjusted close, but you can do it with almost anything, like maybe the number of people in the world, or I mean, I guess that's exponential. It's not a really good idea per se, but maybe the number of cookies that you or a person bakes in a certain number of hours. The list can honestly go on. You can honestly do anything. As long as you have a list of numbers, you can plot that list and then kind of run linear regression on it. And this is probably one of the most simplest ways to do so. Awesome. So this was, once again, linear regression with sklearn. Next time we'll be going over a completely new topic, and also I hope to post another video specifically on linear regression, so kind of keep a lookout for that as well. And the rest of the guys at AI for Aspiring Researchers will guide you really well through the next set of lessons, and I can't wait to show you that and help you with the code for that. So until next time, once again, if you like this channel, please make sure to subscribe, like, leave a comment, share it with all your friends and family. And yeah, see you next time.